Hello everyone. So in this video, I'm going to discuss JEE Mains 2024, 1st February, Shift 2. So I will cover question as per the teaching order. So let us see the first question from units and dimensions. So this is from significant figures and we have to find the number of significant figures in 10.05. And we know that it is measured up to 2 decimal places. So the number of significant figures will be 4. So 4 is the answer of this question. Now the next question is from relative motion. So two trains are moving along a parallel tracks along north to south. So let us say this is north and this is south. And there are two trains. If train A has a velocity 20 meters per second towards north. So train A is going towards north with a speed of 20 meter per second. And train B is going towards south with a speed of 30 meter per second. Now we need to find the velocity of train B with respect to A. So velocity of train B with respect to A will be VB minus VA. So if I consider VB as, if I consider south direction as positive, then we can say it will be 30 minus of minus 20 because VA is in the north direction. So this comes out to be 50. Since the answer comes out to be positive, it will be in the south direction. So it will be towards south and it will be 50 towards south, right? 50 meters per second towards south. So option B is the right answer. Next question is from Newton's laws and it is from the equilibrium. Find the ratio of tensions in the strings. So T1. So how to find the tension in the string? So we have to find the weight which is being hanged from that particular string, right? So below the string T1, first string, the weight is 4 kg, right? So it will be T1 will be 4g, and below T2 the weight is 1 kilogram. So T2 will be 1g. So it will be 4:1. So option 4 is the right answer. Next question is from Newton's laws. A ball of mass 120 grams moving with an initial velocity of 20 meters per second is stopped by an external force F in 0.15 seconds. Find the value of force in Newton. So what we can say, due to the impulse of this force, there will be a momentum change of the body. So we can say F times 0.15 should be equal to the change in momentum. So that will be 0.12 times 25. So from here, F comes out to be 0.12 divided by 0.15 times 25. So this will be 4 and this will be 5. So it is 5. So it comes out to be 20. So F will be 20 Newton. Now the next question is again from Newton's law. So a body of mass 4 kilograms experience two forces F1 and F2 given in unit vector notation. Find the acceleration. So what is the net force? Let us add these two forces. So we have 5, here we have 3, so 8 I cap. 8 minus 4, so plus 4 j cap. 7 minus 3 plus 4 k cap. So the acceleration produced will be, by Newton's second law, will be F net divided by the mass. So mass is 4 kg, so it will be 2 I cap plus j cap plus k cap. So its magnitude will be root of 2 square plus 1 square plus 1 square. So this will be root 6. So option 3 is the right answer. Now next question is from rotation. A solid sphere is rolling purely with a speed v on a horizontal surface. It rolls up an inclined surface and stops at a height h. Then height h is, so here I'm considering that there is no loss of energy when it goes from the horizontal surface to the inclined surface. So if you apply energy conservation, so we can say the loss in the kinetic energy will be gained in the gravitational potential energy. So here, when it reaches at the highest point, here the velocity will become 0. If velocity is 0, angular velocity is also 0. And at this instant, when it is rolling on the horizontal surface, it has certain kinetic energy, and kinetic energy can be given as half mv square. That will be 1 plus k square by r square, where k square, k is the radius of gyration and it is a solid sphere. So k square by r square will be 2 by 5. So that it will be 1 by 2 mv square, 2 by 5, so 7 by 5. So this comes out to be 7 by 10 mv square. Now this kinetic energy has completely converted into potential energy, and let us say it has gone up by the height h, so it will be equals to mgh. So m will get eliminated and we have to find the H value. So H will be 7 by 10 V square by G. 7 by 10 V square by G. So option 2 is the right answer. Next question is from fluids, surface tension. So 1000 drops of water of radius small r each combined to a single drop. Find the energy released if surface tension is S. So what would happen? So 1000 drop will be having more surface area as compared to a single drop. So first we'll apply volume conservation. So volume of 1000 drops will be equals to the volume of big drop. Now this will be 1000 times 4 by 3 pi small r cube, and the volume of big drop will be 4 by 3 pi. I'm taking it as capital R, right? Capital R is the radius of the big drop. So from here 4 by 3 will get cancelled out. So capital R will be 10R. Now the energy released will be what? So we can say it will be the change in the surface area multiplied with the surface tension, right? So what is the change in surface area? So 1000 times 4 pi small r square, that is the surface area of all small drops, minus surface area of the big drop, that will be 4 pi 10r square. So this will be multiplied with the surface tension. So 4000 pi r square minus 400 pi r square times s, so which is 3600 pi r square s, right? So option 2 is the right answer. Now the next question is from oscillation. So we have to find the time ratio of the time period of two simple pendulum, and the only difference between these two pendulum is the mass of bob, and we know that the time period is 2 pi root L by G. It does not depends upon the mass, so the ratio will be 1. So 1 is the answer of this question. Next question is from KTG and thermodynamics. So we have if the RMS velocity of hydrogen gas molecule is V naught, find the RMS velocity of the oxygen molecules at the same temperature. So what is the formula of RMS velocity? It is root of 3 RT by M naught, where M naught is the molar mass. Since temperature is same, R is also constant, so this numerator is constant. So we can say V1 square M1 will be equals to V2 square M2. And we need to find the RMS speed velocity of oxygen. Let us say V2 is the RMS speed of the oxygen. So V2 by V1 will be equals to root of M1 by M2. And molar mass of hydrogen is 2 grams, and molar mass of oxygen will be 32 grams. So V2 by V1, so here it will be 1 by 16, so 1 by 4. So V naught by 4. So option C is the right answer. Now next question is from thermodynamics. So in an isobaric process, work done by the gas is 200 joules. So we know that in isobaric process, the work done is given by nr delta T, which is given as 200 joules. Now if the adiabatic constant of the gas is 1.4, the heat supplied to the gas during the process. So we have to find the heat supplied. Since it's an isobaric process, heat supplied will be NCP delta T. And Cp can be written as F by 2 plus 1 times R delta T. And since and what is the relation between the degree of freedom and gamma value? So gamma is 1 plus 2 by F. So gamma is given as 1.4. So 1.4 minus 1 is equals to 2 by F. So this will be 0.4, that is equals to 2 by F. So F by 2 will be 1 upon 0.4. So that will be 5 by 2. So N 5 by 2 plus 1 R delta T. So N R delta T value is 200. So this will be 200 times 7 by 2. So it is 700 joules. So option 2 is the right answer. Now next question is from electrostatics, and a charged particle mass m and charge q in vertical plane stays in equilibrium in electric field as shown. Find the value of q. A very straightforward question. So it is in equilibrium, so the gravitational force will get balanced by the electrostatic force. So we can say QE will be equals to mg, and we have to find the value of q. So q will be mg by E. So B is the right answer. In the given circuit, find the electric current drawn from the battery. So can you see it's a balanced Wheatstone bridge? So 10 by 10 is same as 5 by 5. So there will be no current through this resistor, or you can say this and these 2 points will be at the same potential. So we can say 10 and 5 are in series and this 10 and this 5 are in series. So we have 15 and 15 are in parallel. So this will be 15 by 2. So that is R equivalent. So what is the current? So current will be V by R. So that will be 20 by 15. So that is 4 by 3. So 4 by 3 is the answer. Right. So the next question is again is from current electricity, and it is from Wheatstone bridge again. A Wheatstone bridge is in which the resistance PQ is temperature dependent. If temperature is increased from 0 to 25 degrees Celsius, then deflection in galvanometer becomes 0. So when the deflection in galvanometer becomes 0, then this Wheatstone bridge will be balanced. So let us say this value becomes X. When it becomes X, the Wheatstone bridge will become balanced. So we can say 0.8 by 1 will be equals to X by 3. So from here, X becomes 2.4 milliohms, right? And we need to find the temperature coefficient of resistivity. Now this resistance is being increased from 2 milliohms to 2.4 milliohms. So the change is 0.4 milliohm. So if we want to find the temperature coefficient, let us say that is some value alpha, it will be the change divided by the original value, that is 2 milli, divided by the increase in temperature, that is 25, right? So that should be the answer. So this change is 0.4 milli and we have 2 milli in the denominator and there is 25. So this milli will get cancelled out. So we have 0.4 divided by 50. So if I multiply and divide by 2, we have 0.8 by 100, which is 0.008 per degree Celsius. So option A is the right answer. So next question is from a meter bridge. In meter bridge shown below, the null point is at 40 centimeter from A. If R is shunted by 2 ohms, find the distance of the new balanced point from A. So at present it is a balanced Wheatstone bridge. So this 2 by 40 will be R by 60. So 2 by 40 is equal to R by 60. So what is the value of R? So this is 2 and this is 3. So R is 3 ohms. Now what we have done, we have shunted 3 with 2 ohms. So the equivalent will become 2 times 3 upon 2 plus 3. So this will be 6 by 5. So 6 by 5, now this R will become 6 by 5, right? In this bridge, the resistance will become 6 by 5. So let us say this value is X. So 2 by X is equals to 6 by 5 upon 100 minus X. So 200 minus 2X is equals to 6X by 5. So if I divide by 2, so this becomes 100, this becomes 3. So 500 minus equals to 9X. So X will be 500. Let me check 8X, not 9X. 500 by 8. So this will be 250 by 4. So that comes out to be 662.5 centimeter. So this is the new balanced length. Next question is from electrostatics Gauss's law. So there are two cubical Gaussian surface carrying charges as shown. Find the ratio of flux through the surface C1 and C2. Now if you look at the charge which is enclosed by C1 is 2q and the charge enclosed by C2 is 2q plus 3q. So the flux, so phi 1 by phi 2, it will be phi 1 will be 2q by epsilon naught and phi 2 will be 2q plus 3q by epsilon naught. So it will be 2 by 5. So 2:5 is the answer of this question. Now the next question is from current electricity. Find the ratio of the charge. Okay, right. So it's the combination of capacitors and the resistor. Charge on 4 microfarad to that of 2 microfarad. So this is 2 microfarad, this is 4 microfarad. So in steady state, there will be no current in the capacitor branch. So if I show you the direction of the current, so current will flow along the resistors like this. Galvanometer has some resistance 2 ohms. So this is the path followed. This is the path followed by the current. Let us say the current is I. So the total resistance of this path will be 4 plus 2 plus 4, 4 plus 2 plus 2, that is 8. So the current will be 8 by 8. So that will be 1 ampere, right? So let us find what is the resistance. So what is the potential drop across 4 microfarad capacitor? Let us, this point is A and this point is B. So we are going from A to B along the current, right? So VA minus 1 times 4 minus 2 times 1 will be potential at B. So put VAB will be 6 volts. So that is the potential drop across the 4 microfarad capacitor. Now, if I move from C to D along the current, so we can say VC minus 1 times 2 minus 1 times 2 is equals to VD. So VC, the potential drop across 2 microfarad capacitor will be 4 volts. Right, so we want to find the ratio of the charge. So Q1 by Q2 will be 4 micro times 6 divided by 2 micro times 4. So this comes out to be 3. So 3 is the answer of this question. Okay, next question is from electromagnetic waves. So a source produces electromagnetic wave of frequency 60 megahertz, wavelength of the wave in vacuum. So we know that for an electromagnetic wave, lambda times the frequency is the speed. So frequency is given, so lambda will be 3 into 10 raised to power 8 divided by 60 mega. Mega is 10 raised to power 6. So this will be 20. So we have 100 by 20. So that will be 5 meters. So 5 meter is the answer of this question. Yes, so the next question is from wave optics and it is from Young's double slit experiment. So we have given slit separation 4 centimeter. So D is 4 centimeter. Separation between the slit and the screen is 1.5. So capital D is 1.5 meter. A wave of wavelength 2 centimeter is incident on the slits. Then find the angular width of the fringe. So angular width of the fringe is lambda by small d. So lambda here is given as 2 centimeter and D is given as 4 centimeters. So it will be 0.5 radian. Got it? Option 4 is the right answer. If the power of light source is P, and this question is from, you can say dual nature, photons. If the power of light source is P and frequency of photon emitted is F, the number of photon emitted in time T. So number of photon emitted per second is given by P upon HF, right? Power upon energy of one photon. Now, if I multiply this with T, we will get the number of photon emitted in time T. So P upon HF times T. So option B is the right answer. Now, the next question is from atoms and it is from the transition of the electron. In transition from 2 to 1 in hydrogen atom, frequency emitted is F0. So that frequency for the transition 3 to 1. So let us see. So from 2 to 1, so we know that 1 by lambda is equals to R times 1 minus 1 by 4. So that is the wavelength. And lambda can be written as C by frequency, right? So frequency will be F0 will be CR 3 by 4. Similarly, for the transition 3 to 1, frequency will be CR times 1 minus 1 by 3 square. That is 8 by 9 CR is F prime. Now CR is 4 F0 by 3. So let us substitute this value. So 8 by 9 into 4 by 3 F0. So this will be 32 by 27 F0. 32 by 27 F0. So C option is the right answer. Now next question is from nuclei and it is theoretical question. So which of the following is correct for nuclear force? It is a long range force, that is incorrect. It is a short range force. It is a short range force and is independent of charge. Sorry, it is dependent on charge. This is incorrect. It does not depends upon the charge. It is same for neutron, 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 proton and proton, proton, right? So C is the right answer. So have you seen whatever shift that we have discussed? So we have discussed 10 shift, including this one. So the level, I would say it is easy and if you are scoring above 80, that is a very good score in these papers. Thank you for watching.